Hello everyone, my name is Ralph Ahmed and today I will be presenting my discussion topic on generalized linear models in practice. For this presentation, I selected Home and Hearth, a heating oil distributor serving rural communities in the United States. The purpose of this presentation is to demonstrate how generalized linear modeling can help organizations improve decision making and reduce operational risk. I'll begin by discussing how Home and Hearth used predictive analytics to address business challenges. Then, during the final portion of the presentation, I'll share my screen and demonstrate how I completed the Unit 2 assignment using R to develop and interpret a linear regression model. Generalized linear models in practice. Home and Hearth operates in the energy industry, where accurately forecasting customer demand is essential for maintaining profitability and customer satisfaction. The company faces several operational challenges, including predicting heating oil demand, preventing inventory shortages, minimizing excess inventory, and improving overall planning. To address these challenges, Home and Hearth implemented predictive analytics using a generalized linear model. Rather than relying solely on historical experience, the company used statistical modeling to better understand which factors influence heating oil consumption. By identifying relationships between customer characteristics and fuel usage, the organization was able to make more informed business decisions while reducing uncertainty and operational risk. Identification and understanding. The first stage involved identifying the organization's major risks. Home and Hearth identified several risks, including inventory shortages during periods of unusually cold weather, excess inventory during warmer seasons, fluctuations in crude oil prices, weather uncertainty, and increasing competition from natural gas providers. After identifying these risks, the organization sought to better understand what factors actually drive heating oil demand. Historical customer data was analyzed to determine how outdoor temperature, insulation quality, home size, home age, and household occupancy influenced fuel consumption. This understanding provided the foundation for building a predictive model capable of forecasting future demand more accurately. Data preparation. Once the risks were understood, the next step was preparing the data. The organization collected historical customer information, including heating oil usage, outdoor temperature, insulation rating, home size, home age, and the number of occupants living in each home. Before statistical analysis could begin, the data had to be cleaned and validated. Data preparation included checking for missing values, ensuring variables were measured consistently, and organizing the information into a structured data set suitable for regression analysis. Preparing accurate and reliable data is one of the most important steps because the quality of the predictive model depends heavily on the quality of the underlying data. Data modeling. After preparing the data set, Home and Hearth developed a generalized linear model using linear regression. The dependent variable was heating oil usage. The independent variables included outdoor temperature, insulation rating, home age, home size, and the number of occupants. After fitting the model, the results showed an R-squared value of approximately 0.8145. This means the model explained about 81% of the variation in heating oil usage, indicating strong predictive capability. The analysis also showed that 4 of the independent variables were statistically significant predictors of heating oil demand. Application. Once the model had been validated, Home and Hearth applied it to improve business operations. Instead of estimating customer demand based solely on previous experience, managers could now forecast future heating oil consumption using measurable data. This allowed the company to optimize inventory levels, reduce shortages during colder periods, minimize excess storage costs, and improve purchasing decisions. Overall, the generalized linear model became an important decision support tool that reduced uncertainty and strengthened operational planning. Next, I will demonstrate how I completed the Unit 2 assignment. So here you see my RStudio screen. For the Unit 2 assignment, the first requirement was to download the heatingoil.csv dataset and import it into R using the required command. So the command was, I'll put it here in the RStudio. And just to explain what that command means, the read CSV function imports the dataset into R. The file choose function opens a browser window, so I can select the heatingoil.csv file, and the header equals true tells R that the first row contains the column name. So I'm going to import the heatingoil.csv file, and I just did that. The read.csv function imports the dataset into R, like I said earlier. So now I'm going to run this command. Heading heating oil. So using this head function allows me to verify that the data imported correctly by displaying the first 6 observations. So if I hit enter, we see the first 6 observations. And now I'm going to run names, the names command. So I reviewed the variables contained in the data set. These include heating oil usage, insulation rating, outdoor temperature, number of occupants, home age, and home size. Now I'm going to run the str command. And so the str function displays the structure of the data set and confirms that each variable has the appropriate data type. The next requirement was to build a linear regression model that predicts the heating oil usage using all the remaining variables. So for that, I run this command. And then I'm going to run a summary command. And here we see with the summary function, it provides the regression output, including coefficient estimates, p-values, the r-squared value, which is right here, and overall model statistics. So the coefficient estimates tell us how each independent variable influences heating oil usage while holding the remaining variables constant. The p-values indicate whether each variable is statistically significant. Variables with p-values less than 0.05 are considered significant predictors. In this model, outdoor temperature, insulation rating, home age, and home size were statistically significant. The number of occupants had a p-value greater than 0.05, meaning it was not statistically significant and could potentially be removed from future versions of the model. The r-squared value is approximately 0.8145. This means the model explains approximately 81.45% of the variation in heating oil usage, indicating a strong predictive capability. The final requirement was to research the energy industry and explain how this regression model could help Home and Hearth respond to business risks. So what you see here on the screen is my Unit 2 assignment paper. specifically the section where I talk about SWOT analysis and risk identification. The SWOT analysis identified several issues and risks, including fuel price volatility, inventory management, weather uncertainty, and competition from natural gas. The two primary risks addressed by this regression model are inventory shortages and excess inventory. And so by forecasting customer demand more accurately, the model allows Home and Hearth to purchase and distribute heating oil more efficiently, reducing shortages during periods of high demand while minimizing storage costs and spoilage during periods of lower demand. So we can see here I've identified strengths and weaknesses, and then I talk about opportunities and threats. So in conclusion, the generalized linear models provide organizations with a powerful method for identifying risk, understanding the factors contributing to those risks, preparing reliable data, building predictive models, and improving strategic decision making. For Home and Hearth, predictive analytics helps reduce two critical business risks. Number one, inventory shortages, and the second one is excess inventory. By applying statistical modeling to historical customer data, the organization can forecast future demand more accurately, improve operational efficiency, and make evidence-based business decisions. By completing the Unit 2 assignment, this strengthened my understanding of how quantitative risk analysis and regression modeling can be applied to solve real-world business problems. Thank you for watching my presentation. I appreciate your time and attention. Bye, everyone.